So in this course, you're going to have a number of lab reports. We're probably going to do at least 2 labs per unit, sometimes more than that. So they're going to end up counting for a fair chunk of your mark. So it's important that you understand what the expectations are in terms of what you need to produce, okay, and then kind of what each part of that lab report should look like, right? Because after kind of talking to our junior high counterparts, lab reports is not something that was heavily emphasized in junior high. They are very heavily emphasized in high school. Okay, so it is very important that you follow along today. Make a few notes on that sheet I just gave you about what you need to do for each section of a lab report. Okay, so the purpose of doing a lab is to investigate a certain problem, figure out why it's happening. All right, so the first thing that you would write in your lab report would be, okay, the problem, and you would state it as a question in your own words, because I would give you a lab handout, okay, that would say, here's the problem we're investigating. You'd have to read that problem and then restate it in your own words, okay, as a question. So let's say we're doing an experiment, a very simple experiment, and the problem is, what is the effect of light on plant growth? Kind of an obvious one, but let's say that that's what we're doing our experiment on. All right, so that's our problem. Then we have to come up with a design. Okay, in the design is where we identify our manipulated variable, our responding variable, and our controlled variables. The manipulated variable is the thing that we as the experimenter are changing. Okay, so it's whatever is being changed by the experimenter in this experiment. The responding variable is the thing that we're measuring. We're trying to find out what the effect of the other thing is on this. Okay, so the responding variable responds, hopefully, to our change or to our manipulation. Controlled variables are the things that we have to keep the same throughout the experiment because they could affect our results if we didn't keep them the same. All right, so if I'm looking at this experiment here, the effect of light on plant growth, the manipulated variable here is how much light they get. Yeah, because that's what I'm testing. I'm going to change how much light a bunch of different plants get. Right? Because my experiment wouldn't be as simple as here's a plant that's going to be in the light and here's a plant that's going to be in the dark. Right? They're probably both going to die. Okay? If I give one plant 24 hours of light all the time, it won't survive. Okay? And if I give one plant no light at all, it will obviously not survive. That's not a very good experiment. So I would probably want several different plants. They're all going to get a different amount of light. Okay? In that way, I'm manipulating the amount of light received by a bunch of plants. Okay? So let's say I've got a plant that gets no light. It's going to die. Okay? Plant that gets 4 hours, 8 hours, 12 hours, 16, 20, and 24. So they all get like, a slightly different amount of light. I've got these plants. Okay? What I'm studying here is how much do they grow? Are there a few ways to measure that? Okay? A responding variable can be measured in a number of ways, and I may measure it in an experiment more than one way. Okay? I could have a qualitative measurement. Okay? That qualitative means doesn't have any numbers. So I would maybe take pictures of the plants every day, okay, or every couple of days, and just see if they look different. Is their color changing? Can I compare? Things like that. Those would be qualitative observations, things that are affected by my manipulated variable, but that I can't really measure per se. Then I would have quantitative observations, like how tall does the plant get? How many more leaves did this plant grow than the other plant? Did its mass change? Maybe I take the mass of the plant in its pot every single day and compare that over the long term, something like that. Those would all be ways for me to gauge the growth of the plants. Everyone follow on that? All right. Controlled variables, like we said before, are anything that could affect the growth of the plant other than light. I need to keep them all the same. That means all the plants need to get the same amount of water, same temperature, okay, same air mixture, all right, things like that. Anything else that could affect the growth of a plant, I need to keep the same. Otherwise, I won't know whether it was the amount of light I gave it or the fact that I watered that one twice as often as I watered that one. Okay, I'm not going to know which affected it, the water or the light. So I keep all the other factors the same. Those are my controlled variables. In any lab report, you will be required to list the manipulated variable, that is, identify it, and explain why it's the manipulated variable, right? So in this experiment, I would write The manipulated variable is the amount of light given to the plants because all subjects will receive different amounts of light and light powers photosynthesis. So I identified it, it's light, and then I explained why. It's the thing that I'm changing, and I'm changing it in this way. Everybody follow? Same thing for our responding variable. We identify what it is, okay? So it's the growth of the plants, because plants getting more light will have more energy for growth. And I might also write in here, this will be measured by mass of the plant, height of the plant, number of leaves, or whatever. I would also write in there how I'm gauging the change. And then our controlled variables, like we said, are other factors that could affect the outcome of the experiment if they were left unchecked. So I can't compare a pine tree, a carrot, and a pumpkin plant because they all grow differently. Okay? It wouldn't be a fair experiment to have all different species of plants in this experiment. I need to make sure all my plants are of the same species. If at all possible, they're genetically identical. With plants, that's actually possible. If you take cuttings of a plant, you can actually get all of them to grow and they would all be genetically identical because they came from the same plant. Okay? That would be the best way to run that experiment. Other controlled variables, same amount of water. We know water is something that affects the plant. So I mentioned in here, same species of plant because different plants grow at different rates. So I've identified here's a controlled variable, here's why I'm controlling it. Okay, same amount of water because water affects plant growth. Okay, same soil because plants get nutrients from soil and different soils hold water differently. Again, it's another thing that affects plant growth. So I need to make sure it's the same for all the plants in my experiment. Same temperature, as plants typically slow their growth in extreme heat or cold. Choosing an effective temperature for all plants ensures it does not affect the experiment. So I explain each one of them. Right? That's an important thing for you to know. You might want to write that down. Okay, you identify and explain each variable, right? Including all three controlled variables. Because what happens very often is I have somebody who writes down 3 controlled variables and then says, because I'm keeping them all the same as their explanation. And they spell it C-U-Z. Okay, not something that impresses me on a lab report, because okay, we don't want to do that. Right? Use good English on your lab reports. Okay, and everybody understand the first part. So this part is what we call the design of the experiment. The design of the experiment is 5 marks. Okay, most of your labs will be out of 30. Okay, so that's 1/6 of the marks on your lab report is getting the variables properly identified and explained. It's essentially 1 mark per variable. Okay, the next thing that you have to have is what we call a hypothesis. A hypothesis is a hypothetical statement about your problem. Right? So the problem I'm investigating is what's the effect of light on plant growth. So my hypothesis needs to tell me what I think that is. Right? So a hypothesis always includes these 3 words. If, and, then. That way it can be a hypothetical statement. For example, a hypothetical statement could be something like this. If listening to music while studying distracts people from the task at hand, and one student listens to music while studying and another student does not, then the student who does not will do better on the test. Okay, that would be a hypothetical statement. It contains an if part, if this is true. It contains an and part that describes the experiment I'm going to run. I'm going to let them study like that, and then I'm going to make them write a test. Okay, and then the then part says, here are my results. If this is true, then this is going to happen. Right? If that doesn't happen, then my hypothesis is no good. Okay? And that hypothesis is pretty bad. Okay? I studied with music on all the time. Okay? Some people do, some people don't. Right? Everybody okay with that idea? So a hypothesis always contains if, and then. For our light experiment, okay, we might have it look something like this. If plants require light for growth, and we know that they do, okay, and 5 identical plants are given different amount of light, then the plants that receive the most light will show the most growth. All right, so it's a reasonable statement. It's probably not true, but we'll find out. Okay, if we ran an experiment, we would find out whether it's true or not. All right, so this part here, guys, just tells you what goes in the if part, okay, what goes in the and part, and what goes in the then part. Okay, so what's the relationship between the manipulated and responding variable? That's if. Okay, briefly describe the experiment. That's the and part. Outline the expected results. That's the then part. 5 marks. Okay, so your hypothesis, which is basically kind of a long sentence, it's one sentence, okay, is 5 marks. Okay? It is arguably the most important part of the experiment. Without a good hypothesis, running an experiment is useless. It won't prove anything. Okay? That's what was wrong with alchemy. They never had any hypotheses. They just said, I'm going to mix this stuff together today. Okay? You don't kind of get anywhere. You don't make any progress with that. Okay, so if and then, like we said, that's okay what we want to have in each part. If, cause of the problem or the relationship, and briefly describe the experiment, then what you expect if you're correct. Right? We generally try to avoid the use of I, us, or we in a hypothesis. Reason being, the hypothesis governs everything that happens in your experiment. In good science, an experiment needs to be repeated in order to find out whether it's valid or not. And having the same person repeat it doesn't help its validity. So you usually have to have somebody else try your experiment and see if they get the same results. If you put, I'm going to do this in your hypothesis, every time someone repeats your experiment, who has to be there? You. Doesn't make it repeatable without you being there. Right? So you try not to include I, us, we, or whatever, okay, any specific people, or it's hard to repeat the experiment. Okay. So in a hypothesis, what I don't want to see is, I think this will happen. Okay, that's the worst thing you could write in a hypothesis. I don't care what you think. I only care what you can prove scientifically through a lab. Okay, and that's what we want to say in our hypothesis. If this is true and this is done, then this is what's going to happen. All right, if you think something else is going to happen, good for you. Don't write it down. Okay, just find out after. Then you're going to have the procedure. Okay, and in the procedure, those are just the step-by-step, very explicit directions on how to perform the lab experiment. Okay, there's only one lab in this course where you actually have to design the procedure, and it's the first one we do. Okay, and I'll walk you through it. Right, the rest of them, it's pretty cookbook. I've already got the procedure. You just follow step 1, step 2, step 3. Okay. Everybody with me there? There's not really much in terms of marks in the procedure. You either follow it or you don't. Okay. When you're doing the procedure, you're going to develop observations. Sometimes that's a chart, sometimes it's graphs, maybe it's pictures, okay, something like that. That's going to be 3 marks. It's basically how I know if you did the experiment right or not. Procedure, no, there's no marks for that. That's just the instructions you follow. Okay? If you follow the instructions, then you get the observations. And if you followed them correctly, you get the correct observations.
What is design again?
Design is the variables. That's 5 marks. Okay? All right, then we have your analysis. Okay? Sometimes that's calculations, building a graph, something like that. Other times it's comparisons of data. So you're looking at, okay, at the start I had this and at the end I had this, right? Things like that. But there's any number of ways that you analyze data. It honestly depends on what kind of lab you're running, right? Most of the time it's going to be some questions that you're going to have to answer. So I would give you the questions and then you would look at your data and answer the questions as a form of analysis. Okay? Those are going to be worth 5 marks. Your answers do need to be detailed. Okay? I can't stand it when I get someone's lab report handed in and I get for a question the answer, yes. I never ask on a lab report yes or no questions. Okay? Yes, because that would be fine, right? But make sure you have some explanation as to yes. The only thing worse than yes would be I don't know. Because usually by that point you should. Okay. After the analysis will come your conclusion. Okay. The first thing you do in your conclusion is you restate your hypothesis, which basically just copy and paste it. Okay. Go back up to the start of the report, copy it, paste it back down in there. And then you have to tell me whether your data and analysis support your hypothesis or don't. Okay, so if your data, so let's say we did this lab with the plants, and I said that the more light they got, the more they would grow. But my data says that they didn't grow at all if they got less than 6 hours of light. They grew really well if they got between 6 and 18 hours, and they died if they got more than 18 hours. Is my hypothesis supported? No, because I said the more light they get, the better they'll grow. And that wasn't true. It was true to a point, 18 hours. And after that, it wasn't true. So my hypothesis is not entirely supported. So what I would say is the data shows that there's a range of light exposure that is good for plants that is between 6 and 18 hours. Anything more than 18 hours or less than 6 seems to be harmful or detrimental to the plant. More research will be required to find out why. Okay, my hypothesis is not supported. Right, so I said, here's my data, here's what my data says, and it says my hypothesis is not right. Okay, and then you can always say, more data or an experiment like this might be performed in the future, something like that. All right, your conclusion is out of 4 marks. What I do not want to see for a conclusion is, I was right. Okay, and I see it all the time, even though I say, don't write, I was right. Okay, you're never 100% right in a lab. There's no right and absolutely wrong in science, right? It was either supported or not supported. If you write, I was right, I'm going to say, no, you weren't. Okay, and probably give you like 1 out of 4. Right, so please don't write, I was right. Also, don't write, I was wrong. You want to give me an explanation, okay? My hypothesis was not supported because the data says this, right? So your conclusion looks back at your data, looks back at your analysis, and tells me why or why not is your hypothesis supported, is it not, okay? Last thing that needs to be done is your sources of error, okay? We call that the evaluation, right? So in there, you're going to write, here were some things that happened during the lab that interfered with getting good data, or may have interfered with the results and given false data. Okay? Identify those and explain how could they be fixed. All right. So what we could have in this experiment with the light would be artificial light was used in this experiment. Artificial light is different than natural light. Perhaps that may have given some false results. Another experiment could be performed where natural light was used. Now, it'd be a little harder because you'd have to cover plants up with boxes to keep them out of the sun. But okay, and it'd be hard to get 24 hours of sunshine unless you were, near the North Pole in the summertime or something. Okay, everybody kind of follow there. Okay, so you'd have to mention in there, here's a source of error. The thing you don't want to mention as a source of error is human error. You only want to mention sources of error that were beyond your control. The procedure said do it this way, and I did that. Okay, so you can't mention something like this because I see this all the time. Yeah, we forgot to do step 2. So our data is probably wrong. Okay, and you laugh, but I get people who write that. And you know what that says to me? Quote error, I screwed up, and I know it, and I was too lazy to do it again. Okay, that is not the impression you want me left with when I'm marking your lab report. Because if you tell me I screwed up and didn't fix it, I'm going right back into your lab report and looking and seeing, oh, well, yeah, that data's wrong, that data's wrong, that analysis is wrong, and all of a sudden, your lab report is no good. Okay, so you don't want to say, hey, I screwed up and I didn't fix it. Right? Don't use any human sources of error. Okay, list other things. For example, if we were measuring how far a cart went with a ruler, right? You don't want to say we didn't measure very accurately. You don't want to say that. That's human error. But you could say the meter stick is only accurate to plus or minus 1 centimeter. This could be more accurate with a meter stick that has millimeter marks on it. Okay, there's a source of error. You were given this instrument to use in the lab report. That made it you were only able to be this accurate. Okay, source of error, right? There was nothing you could do about that. You did your best with that equipment, right? But saying we didn't measure very accurately is different than saying the tool I was given didn't measure very accurately. Everyone follow? All right. So when you're doing a lab report for me, okay, you'll get something like this. Okay, so you'll get in Google Classroom a template. All right, and it'll say whatever the lab name is, but it'll say Science 10, and then it'll say problem, and it'll be blank. You'll have to write the problem in your own words in the form of a question. And then there'll be the design, manipulated, responding, and controlled. Explain your choices. So that's where you would write light is the manipulated variable because different plants are getting different amounts of light, blah, 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 okay, and so on and so on. Then underneath that, you'll have the hypothesis, and usually I'll remind you that it's supposed to be an if, and then statement, so you put your hypothesis in there. Materials and procedure, you don't have to generally write, because I'll have already put them in. And then you'll have space for your data, okay? So sometimes you have to copy and paste data in like I've done here. Maybe there's a graph you have to put in, okay? Then you'll have your analysis, the questions you have to answer, or the paragraph you have to write, or whatever it is you have to do to analyze your data. That would go in there. Then you'll have your conclusion. So you put your conclusion in here, copy and paste your hypothesis, explain, and then your evaluation, right? So that's your sources of error, right? So you'll always get that template, okay? The reason I give you the template is so you don't forget any parts. The parts are always listed there. Don't leave anything blank, okay? If it's listed there, you need to write something for it. Once you've got that all done, then you submit it to me. Okay, this is the only way that I will accept lab reports, is submitted electronically through Google Classroom. I do not take paper. Right? I'm giving you this template to save you time. All you have to do is fill it in. Okay? Then when you're done, you click turn in, okay? And it comes to me, and I mark it, and then I return it to you electronically. You save a whole bunch of trees. Okay? The really nice thing about this is your dog can't eat it. You can't lose it. Okay? And I can see everything you do. That's a little creepy, but I can see everything you do on here, okay, on this lab report. All right. So it kind of helps me to police plagiarism, cheating, and things like that. Okay, so keep that in mind. If you do that, I'll know.
Could you see what we've deleted? If we just
Yes, I can see everything. Okay,
I can some humor.
Yeah, if I'm looking for it, yeah. I generally don't check your revision history unless I'm suspicious of something.
Yeah, but have you ever found just something really weird doing that?
I've actually watched two people copy off of each other. I can see it live. Okay? If you're in this, okay, and you're working on it, I can see it up here because it's my file. I'm sharing it with you. So as that you modify it, I can see it. Okay? And so I had two people, and they were clearly copying off of each other because they were, sharing things across, and they were typing at exactly the same time. And it was like, so I just put in the comments, I'm watching you. A little creepy. Well, they sure stopped copying each other. Okay, so yeah, it's only because I heard them say that that's what they were going to go do during class, because I hear everything. By the way, I hear everything. So okay, keep that in mind too. All right, so that's how that'll work for you. Again, it's designed to save you some time and make sure that you follow the proper format. Okay, the more effort you put into this, the better you're generally going to do. If you just put in one-word answers, that's not going to work out very well. Okay, but these are a big part of your mark, so you want to spend time on them. The first couple of times you do a lab report in my class, it's probably going to take you a while. Okay, so the first lab, we actually get a fair amount of class time to work on it so that it's not all homework. Right? But as we go along, you'll get less and less, okay? But it also won't take you nearly as long. By the time we get into Unit 2, realistically, a lab report should not take you longer than, like after class, half hour, 40 minutes. Okay, really, it shouldn't realistically take you much longer than that. You're just filling in the template and getting it done. Also, over the first few lab reports, if you would like to get me to review it for you, then you just pop in scheduled help and say, Mr. Coderre, can we go over my lab? I can call it up on my computer. We'll go over it together. I'll write some comments in, and you can go back and make the edits after. Just in kind of until you guys get the hang of how to do a lab report, I'll give you that kind of feedback, as long as it's before it's due. Like, don't come to me like 2 minutes before the day on that it's due and say, Mr. Coder, can you look over my lab report? Because the answer will be no. Okay. Also, don't email me at 11:45 at night or 2 in the morning. One kid. Okay. Mr. Coder, can you look over my lab? I'm old. I need sleep, or I'll die. Okay. So don't email me at 11:45 the night before that thing is due and ask me to look it over. Okay. I'm not going to reply because I would say something I wouldn't regret but would be forced to apologize for. Okay, so yeah, just know that I'm not going to do that. I'm not going to electronically, review things for you, because then there's never a time I'm not at work. Okay, I'm playing with my kids and I get an email. Can you look over my lab? Like, I'm not putting my kid aside to look over your lab. Okay, like, just not going to do that. Right, come in and scheduled help or lunch. I'm happy to do it then. Questions on lab report expectations? All right, so those are the sections. Okay, you'd be evaluated like this. Design's 5, hypothesis is 5, your data and observations are 3, analysis is 5, conclusion 4, evaluation 3, and overall. Okay, your overall is kind of things like grammar, spelling, format, okay, things like that. Just make sure that you kind of do a good job. It really makes a bad impression when you hand in a lab report and when I open it up, the spell checker's got half the document highlighted. Okay, that really says, hey, Coder, I put no effort into this. I didn't even run the spell checker. Okay, I saw all these words misspelled and just didn't do anything about it. This is not the first impression you want me to have when I open your lab report. Okay, so look for things like that, because that's where the overall mark kind of comes in. Okay. All right, so next week we will be starting on that. On Monday, we'll sit down and we'll start working on, Monday or Tuesday, we'll start working on the lab report, the first lab report. Okay, we'll walk through what the procedure is, what the hypothesis is, stuff like that. Then we'll run the lab and we'll come back and talk about the analysis and things like that. Okay, remember that every time we do one of these, I will also record, okay, me giving you the instructions and all the hints and tips for the hypothesis and variables, all that. That'll always be recorded. You can always go back and listen to that while you're putting your lab report together, and that's a good idea as well. Right? Okay. If there's no questions on that, then let's get back to working on the naming. But let's skip ahead so that we're now to some that are, I gave you the formula and now you're writing the name. Okay, I think we've done enough of the other one. Okay, let's do some of those.